Well, hi there. My name's Tom. My ham radio call sign's Mike Zero, Romeo, Mike Yankee. And I thought I'd just write a little talk on really what are radio waves from the basics of simple physics, a little bit of quantum mechanics, and I hope this is of use to you as you learn a bit more about radio and how it works. Originally, I wrote this to give at our de-expedition in Cornwall last year, but for obvious reasons that got cancelled. So here we are. I'm trying to put it together as a video, which I hope you enjoy. Despite all the advances over the last 200 to 300 years in physics and technology, it's interesting to note that actually we don't fundamentally know what the universe is made of. We understand atoms, electrons and protons, etc. But the fundamental particles of matter still escape us, and we don't really know what it's made from. But never mind, because we do know how to manipulate matter, and specifically for this talk we know how we can manipulate charged particles such as electrons in order for them to create electromagnetic fields and transmit data, voice and information through the atmosphere. This is really what I thought I'd try and understand with this talk, and get a grip on what are the actual wiggles that we produce from our antennas on a more fundamental basis. So here we go. I wonder if Albert cracked time travel. Given that he said this in the early 1900s, it just strikes me that he may have lived in 2020. Everything's made up of stuff, and all stuff is made up of atoms. The Greeks began to think about this 2,000 to 3,000 years ago, and the word atom just means undivisible in Greek. If you remember your school physics, you'll recall that picture that looks a bit like a solar system with a nucleus in the middle and the orbiting electrons moving around the central nucleus. Although not entirely true, this is a good way to visualize what an atom looks like. And by convention in physics, we say that electrons are negatively charged, protons are positively charged, and the neutrons that are in the nucleus with the protons carry no charge at all. So the electrons, as you see, exist in orbits around the nucleus. Hold on to your hats, they don't actually, they're quantum wave functions waiting to collapse. And if you want to learn quantum mechanics, I wish you well. According to Niels Bohr, the electrons were just not able to wander around anywhere, and they must stay in what he described as discrete orbits. And in fact, Pauli, his friend, also realized that they had to stick to certain energy levels within the atom itself. So the orbits that are nearest the central nucleus exist in what are called low energy states. And in order to push an electron up and away from the nucleus, you have to give it energy, in the same way that a rocket leaving Earth for space needs to have energy to escape the force of gravity. So from this we can see that if an electron moves up and away from the nucleus, you need to give it some energy. But if subsequently it moves back down again, it will emit some energy. And the energy that it emits is called electromagnetism. Max Planck worked out that the energy it emitted was equal to the result of his equation HF, where H is a constant, just a number, and F is the frequency of the electromagnetic field that is emitted subsequently. So what's all this got to do with radio waves? Well, if you remember, an electron is simply a charged particle. And we know that if we move electrons around inside the atom, they have an ability to emit energy in the form of an electromagnetic wave. The bandwidth of the frequencies that you can get are simply the electromagnetic spectrum, and this is where the connection between atoms and electrons in orbits comes when dealing with radio waves and the spectrum that we know and use in our daily lives. James Clerk Maxwell studied magnetism and electricity, and he realized that he could combine the two to form his theory of electromagnetism. He also realized that if you accelerate a charged particle in the same way that an electron is accelerated within an atom, the subsequent energy emitted is an electromagnetic wave. If you think about electrons moving in a copper wire, you are simply accelerating a charged particle, and this is where we get the link between atomic physics, electromagnetism and radio waves at all frequencies. So in fact a radio transmitter is just a machine that applies energy to a charged particle that we call electrons. The electrons are accelerated, they move through various wires, some of which we call antennas, and in doing so they emit electromagnetic waves. They're simply a moving charge that, according to Clerk Maxwell's theory, is obliged to emit electromagnetic waves at a specific frequency. All our transistors and transceivers do is manipulate that frequency and the wavelength by alternating the speed that we move and jiggle them around. It is actually that simple. You may have seen this circuit before if you've studied ham radio or any kind of radio physics. This is a tuned LC circuit. It consists of a capacitor and an inductor, and if you apply alternating current to this circuit, the movement of the electrons, which are just charged particles, induces a magnetic field in the inductor. This then collapses and charges the capacitor, which then discharges as the direction of flow of charge alternates. As the capacitor discharges, it induces a magnetic field on the inductor, and so on and so on. The overall effect is simply to accelerate the charged particles that we call electrons within the wire and the circuit. And as we know from Clerk Maxwell's work, if you accelerate a charged particle, you cause an electromagnetic field. We can manipulate the frequency that the electrons move through the wire to cause our desired frequency and our desired electromagnetic field to be produced. That's it. So once we've induced the charged particles to move at the frequency we want, we squirt them up the wire we call our antenna. And as they move and accelerate through the wire, they emit electromagnetic waves in the form of radio waves. Of course, the electromagnetic spectrum has a wide range of frequencies and wavelengths, but the interesting ones for us in our hobby are those that we call radio waves. This picture of a dipole antenna simply shows the charged particles in the form of electrons moving backwards and forwards through our dipole and subsequently emitting electromagnetic radiation. Of course, we tune our antennas to be efficient at the very frequency we want them to be on. An inefficient antenna will not radiate as well as one that's been cut to the correct length for the wavelength we wish to transmit or receive on. So in summary, we've learnt that electrons are the charged particles that exist in atoms. And in electronics, electrons are our charged particles that we can manipulate. James Clerk Maxwell showed us that by accelerating a charged particle in a wire, it produces an electromagnetic field. We can manipulate these electrons in our circuits to produce an electromagnetic field at a desired frequency or wavelength. We then squirt these electrons up our antennas, and physics does the rest. Well, here's just a few of the people we've mentioned in the talk today. And just out of interest for ham radio, Ambrose Fleming, who designed Marconi's spark gap transmitter, was one of James Clerk Maxwell's pupils. So there's a direct link between the greats of physics and ham radio. And of course, Max and Niels and Albert set the scene for what is now our modern world of electronics and technology. Well, that's it. I hope you've enjoyed this short talk. It's obviously just a very light skim into the complexities of atomic physics and electromagnetism. My name's Tom, Mike Zero Romeo Mike Yankee. I wish you all 73 and hope to catch you on the airwaves. Thanks.